Hey you guys! So for this Adposal video, I'm actually just going to run through this entire quiz that we had last week, well this week, and I just want to make sure that you guys understand how to work through each of these questions. So I'm going to go ahead and get started so this video doesn't end up being too long. So number one says a certain type of bacteria doubles every 7 hours. And if we started with 36 bacteria, how many would we have after 28 hours? So what I'm going to do first is just go ahead and write out my exponential function. I know that exponential function general format is y equals a times b to the x. A is our initial amount. So what would the a value be for this question? And we also need to figure out what's our b and then what is our x. B is like whether we're growing or decaying. So we need to look inside of our word problem and see if there's any information here that tells us whether we're increasing or decreasing. I'm going to go ahead and circle that word doubles. This should have been my hint for this one. Doubles. That tells me that my b is equal to 2 because I know if I'm doubling something, I'm multiplying it by 2. Now our x, that's what we're going to spend a little bit more time on, and hopefully you guys saw that our a was 36. But our x is what we're going to spend some time on. It says that the bacteria doubles every 7 hours, but we have 28 hours. So what operation do you think will allow us to see how many times our bacteria is going to get a chance to double in those 28 hours? Should we use multiplication, division, subtraction, addition? Hopefully you guys are saying division. So I can do 28 divided by 7 to get 4. And this is the information that I would need to be able to put this equation into decimals and evaluate it. So here my exponent is 4. Just want to kind of make that clear. And I got that again by dividing the total hours, and this is on those guided notes as well, total hours by process time. So that just means how long does it take for it to happen once. But they told us every 7 hours. So we did 28 divided by 7. And if we were to go to decimals, which we're going to do now, and I have that one already up here, 36 times 2 to the 4th, that's that first equation up top. So we see that answer is 576. So I'm going to go ahead and circle that for us. Now, question 2. It says a soccer tournament is starting out with 128 teams. After each round, half of the teams are eliminated. After 6 rounds, how many teams are left? So since this is a math class, what I can do first, if I'm going to solve a word problem, I could start with underlining or pointing out all of the numbers. So I see after 6 rounds, starting with 128 teams, and then half are eliminated. That's actually everything that we need to write this equation out, you guys. So I'm going to say y equals a times b to the x. That's my general format. A, my initial amount. How many teams did we start with? 128. And then my b, that's going to tell me how many teams or how many more teams are joining after each round or how many teams are getting cut off after each round. So right here, though, it says after each round, half of the teams are eliminated. That's our common ratio, you guys. That's the B. So B is just going to be 1/2. Now X represents the number of times it happens, the number of cycles. But they asked us after 6 rounds. So that's the X right there, 6. So now, again, we have everything we need to write this out. So I'm going to go ahead and do so. I have 128 times 1/2, and then my exponent 6. I already put this in the decimals for us to save us time. I can see that it solves out, evaluates to 2. So number 2 is 2. Let's look at number 3. All right, we got a rural town declining. Of course, who wants to stay in the country? At a rate of 2% each year. If the current population is 7,000 people, what will it be in 6 years? Now, you guys, if I don't know anything about this class or anything about this exponential function, it says the town population is declining. If it started with 7,000 people, I need to make sure that however many people I have in 6 years is less than 7,000. So I should be able to mark out answer choice B just because it's greater than 7,000. And we already said our population is declining. So since I see that 2% over here, I'm going to want to use this equation. A times. So I know that we have been exposed to this one, but I want you guys to understand that our B breaks down into 1 plus or minus R. So I want you guys to be able to see that connection. So I'm going to use this right here to go ahead and set this equation up. I need my A, which is my initial amount. I can see that's 7,000. Now, we already kind of just established that our population is declining. Since I'm declining, I wonder, am I going to be doing 1 plus or 1 minus? Hopefully you guys said minus for that. Now, I want to make this 2% a decimal. Would that be 0.2 or 0.02? Hopefully you guys said 0.02. So I'm going to do 1 minus 0.02 because that's the value of RR. Now RR is always just going to be that percent, as a decimal. I'm trying to move this up a little bit. And then our exponent, that's again, our exponent tells us after how much time. But right here it says in 6 years. So our exponent is just going to be 6. And I also know that because my rate is in years. So it says 2% each year. So since my population is in years as well, they're framing that question in years. I know that the exponent is just going to be 6. Now once I put this into decimals, and I've already done so to save us time, I get 6,200.89. Now, since we're dealing with people, we really can't have 0.89 people. We just have 1 person, 0 people, 2 people, 3 people. We're whole persons. We're whole numbers there when we're counting people. So I'm going to go ahead and round up to the nearest whole number, and that'll leave me with answer choice A. There'll be about 6,201 people in that town. Now, question 4. Question 4 says the current population of a town is 10,000. If the population increases by 20% each year, which equation could be used to find the population after T years? So let's just act like they asked us for 3. Because that T years may throw us a little bit off. So let's just act like they said 3, right? So what will we do? Since we see that 20% there, or no, we will automatically think of using this equation here. Let me make sure I'm zooming in. I know that we're going to use so let's go ahead and start by creating that 20%, making that 20% into a decimal. So 20% as a decimal, hopefully we see that is 0.2. So now what I'm going to have to figure out is, should I be adding that to 1 or should I be subtracting that for 1? Because that's going to give me a hint as to what goes inside of those parentheses. So I'm going to come down a little bit so I can go ahead and write out my A. I kind of got ahead of myself. My A is just going to be the current population right now, which is 10,000. And then that's 1 plus 0.2. Oh, this is what I was supposed to ask. Well, it's I kind of said the answer already, but I'm adding because my question says that I'm increasing. And whenever we're increasing, I know that's growth, so I'm going to add. So I'm going to be doing 1 plus 0.2 in those parentheses. Now, we said we were going to change that T years to 3 years. So then I would put a 3 there, right? But the question asked about T years. So I want you guys to not get confused when you see those variables, because what you can do is put a number there. That's what I used to do back in school. When they gave me variables, I put a number, trying to make it make sense to myself. So once I simplify this at parentheses right here, I would have 1 plus 0.2. I know that's 1.2. And this answer choice, this right here, 10,000 parentheses 1.2 to the T power, that's exactly answer choice D. Let's go ahead and look down at 5. All right, a bacteria has an initial population of 500 and is doubling every hour. Which equation could represent the situation described, and how long does it take for the bacteria to reach 16,000? Now, this question right here says that the population is doubling every hour. So, I know we've talked about linear equations, then we've also talked about exponentials and quadratics. So, from linears, I know I had that general equation y equals mx plus b. That told me what to add or what to subtract each time. So B and D are saying they want me to add 2 after every hour, but that's not what we're doing. We're not adding 2 after each hour. We're multiplying by 2 after each hour. So I'm going to go ahead and X out answer choice B and answer choice D because they're linear equations, and I'm looking for an exponential one. That leaves me with A and C. So even if I didn't know what this equation would look like, if I had no idea, I should be able to narrow down between A and C. And now from here, the only difference is A says it'll take 16 hours, so that's saying X should be 16, whereas C is saying X should be 5. It'll take 5 hours. So let's see who's telling the truth, A or C. So we're gonna go over the decimals. I already have it up here. 500 times, let me scroll down a little bit. Eventually I'll get there. Okay, there. 500 times 2 to the x. And my keyboard's gone. Sorry, I had to zoom out a little bit. So the first one said 16. Let's try that. Because we're looking for it to be equal to 18. Oh, whoa. That's not what we want, right? You guys, we want it to be equal to 16,000. So let's see what happens when we try 5 as the exponent. Cha-ching! So it's going to take 5 hours. So 5 actually is answer choice C. Now, when I didn't know in high school, I would always guess C. So if you did do that for number 5, you got it right. Let's look at 6. Number 6 says determine the amount of an investment if $1,000 is invested at an interest rate of 8% compounded quarterly for 2 years. Now, on the front of that study guide, we have 3 different formulas. We said we can use our growth formula, decay, and then we also have that compound interest formula. Which equation do you guys think that we need to use for this one? Growth, decay, or compound interest? Hopefully the crowd is screaming compound interest out there. So let me go ahead and write that equation out. That's A equals my principal amount. How much did I put inside my account? And then parentheses, 1 plus R, which is just that interest rate as a decimal, over N, which tells me how many times I do it in a year. And then my exponent is N, and again, that just represents how much my interest is how many times my interest is compounded in a year. And then T just tells us for how many years. So let's go ahead and find these different pieces. We got to find R. We need P. Let me go ahead and do P first, actually, you guys. So we need P. We need N. I'm so messing these letters up. I'm trying to go in order. R, N, and then T. So how much did we put in the account? $1,000. You get 1,000. You get 1,000. So we put in $1,000 in everybody's account. And then we also have to make 8% a decimal. That's our next step because that's going to be our R. So when I make something a decimal, I'm moving it when I make my percents a decimal, let me be more clear, I'm going to move it 2 spots to the left. So starting here, that's where our decimal's at right now because we're reading this as a number 8. Here go 1 hop, that's 1 jump. Got to do it again. Boop. And here's our number, 0.08. So that's what our R is, 0.08. Now, N, that tells us how many times we're compounding this interest in the year. It says compounded quarterly. If something is happening quarterly, how many times does it happen in a year? So maybe we could think about the number of seasons that represents quarterly. So hopefully you guys are seeing that N is equal to 4. Summer, spring, winter, fall, 4 seasons. Quarterly is 4. And T, after how many years do they want us to check this? 2. It says it right here, for 2 years. And this is exactly like that question from the quiz review. I just changed the number from 1,000 to 2,000 on our review. So hopefully you guys were able to see that connection. So let me go ahead and plug in these numbers. I see I have A equals 1,000, I was going to say 10,000. Oh, I didn't wrote 10,000. I'm manifesting. Everyone's gonna receive $10,000 tomorrow. And then 1 plus 0.08 over 4. And then our exponent, you guys. Let me make sure I'm putting emphasis on this part. So my exponent is going to be 4 times 2. Both of those numbers need to go in the air. When I put this in the decimals, which is what you guys see on line 5, I see there'll be $1,171.65. But if I wanted to round this to the nearest cents, which is what I should do, that 9 right there is going to make us do what? Raise the score or let it rest? Hopefully you guys are saying we need to raise the score. So that's going to turn that 9 into a, that's going to turn that 5 into a 6. So I have 66 cents instead of 65. And that's exactly answer choice B. All right, let's look at 7. 7 is set up just exactly like question 1. So how we had to do that operation to figure out what our exponent is, we're going to do that again for number 7. So I'm going to start off just by writing that general format. And since I don't see a percent in question 7, I'm going to use the A times B to the X. Now, how much bacteria was in our how much bacteria did we have in the beginning? Too much, looks like 8,000. Ooh. We got to get rid of some of that bacteria. And then it's doubling. Ooh. Sorry. So my B is going to be 2. I know that's what number represents doubles. Just happened here. Let me come back up. Oops, that didn't save any of that. No problem. Times 2. And then my exponent is, this is the part we need to work a little bit carefully on. So it says that I have 630 minutes, but the bacteria is doubling every 210 minutes. So I need to figure out how many times is it going to double in those 630 minutes. So what operation do we do, you guys? You know, division. Hopefully you said division. This is equal to 3, hence our exponent is 3. Now I put this in the decimals. I see that that's that last equation at the bottom, that's 64,000. So I need to already go ahead and X out answer choice A, answer choice B. They're wrong. Now C and D, they're gonna lead me to the right answer. I need to figure out if this is a linear function or exponential. But we kind of just said that exponentials, you're adding the same amount each time. We're not adding the same amount each time. We're multiplying by the same amount each time. So what do we do? Which kind of function is this? Hopefully you guys are saying exponential. So number 7, yes, is D. 3 more questions left, you guys. 3 more questions. All right, number 8. A mole population doubles every month, and it says we started with 2 moles. They want a graph of this equation. So, you guys, I don't want you to pay too much attention to the details here because you guys have enough knowledge to be able to attach which graph is appropriate for this scenario. So what I want us to look at first, it says the mole population is doubling every month. So does that mean it's going to is our population growing or decaying? Hopefully you guys say that our population is growing. So one of these graphs is not growing. One of these graphs are decreasing over time. And I can trace it from left to right to determine. So which graph should we automatically be able to eliminate just because that graph is not increasing over time? Hopefully you guys are saying answer choice B, because I can trace that from left to right. I see it's going down. So that's not what we're looking for. Because unfortunately, these moles, they're doubling every month. So we're going to narrow it down. We have A, C, and D now. And I want us to think about that word doubles again. So does double represent linear functions or exponential functions? Hopefully, again, you guys are saying exponential. However, one of these graphs is linear. And that graph is what graph, you guys? Which one of these is a linear graph? Answer choice. Hopefully you guys said C. So for that reason, I'm going to X that one out. So now I have it in between A and D. It says that I started with 2 moles. And remember, I said that in class, we need to figure out what our A is because that's our y-intercept. So that's going to help me narrow it down between A and D. Now, I know it's kind of close, but the graph of A looks as though it is raised a little bit above that x-axis, whereas this one down here looks like it's laying flat on the x-axis. This one looks like it's raised a little bit up. That little bit up reflects those 2 moles that we're starting with. So for question 8, we should have A. Alrighty, let me look at 9 and 10. Alright, so we have a wildflower population tripling every 2 months. It says we started with 12. So what is the graph of that equation? So since we're tripling every month, do you guys think that our population is increasing or decreasing? Increasing. So one of these graphs we need to go ahead and eliminate. That's going to be answer choice D, because D is decreasing. Now, since we're tripling, I need to go ahead and ask myself, is this a linear function or an exponential function? Since I'm tripling, I know that's exponential. So I'm going to go ahead and X out answer choice B, because that's a linear function. So now I'm in between A and I'm in between C. They're both increasing, which is great. But what I'm going to want to focus on is that y-intercept. How many flowers are they starting with? Because I know how many I need to start with. It tells me right here we have 12 wildflowers. 12. What is our graph on A showing? How many wildflowers is it saying we started with? Because right here to me it looks like they're saying we have 0. So hopefully you guys saw 0 as well. Whereas down here it's a little bit raised. So this kind of reflects to me 12. So which answer choice do you guys think is correct? Hopefully you're screaming C. And if you guessed again C for this one, you got it right. Okay. Last question. Which of these graphs correctly shows the table of the values given below? So I want us to take a look at here at these y values. And I'm going to list them out to make it a little bit easy for you guys to see. Because 1/2 is the same thing as 0.5. So I just kind of wrote it as a fraction. So are these values getting bigger over time, or are they getting smaller? Hopefully you guys said they're getting smaller. Since they are, I'm going to want to have a graph that's decreasing. I want a graph that's decreasing. One of these graphs is not decreasing. Letter A is not decreasing. So letter A is not the right answer. Now, I want to ask you guys again. Is this graph decreasing the entire time, or does it start to increase? No, it's just decreasing straightforward the entire time. So I'm going to mark out B because right here it's saying that it's increasing. But that's not the case for us. So B cannot be correct. So I'm going to want to think that the answer for number 10 is C. But to confirm that, I can check that y-intercept. So what does and you guys really can't see that. And I kind of share this with the in-person students as well, with any student who got to this question. This graph is a little blurry, and I do apologize for that. But I wanted you guys to just kind of look at those observational skills and be able to determine which one of those graphs is correct. And that is going to be answer choice C. But I can understand how you guys weren't able to see that. So that actually wraps up this quiz review. I'm going to go ahead and stop it now. And for those students who watched this through its entirety, I'll be giving you half of the credit for the questions that you didn't miss. So if you got a 40, now you got a 70. If you had a 60, now you have an 80. If you have a 90, now you have a 95. So enjoy the rest of you guys' weekend, okay? Take care.